All right, let's talk about GitHub Copilot. It's this incredible AI assistant that's supposed to completely change the game for how we write software. But, with that kind of power comes a pretty big question, right? Is this tool a helpful partner, or is it a security risk just waiting to happen? Let's dig in and find out.
So the basic idea behind it is simple, but wow, is it powerful. As you're typing away in your editor, Copilot is right there with you, suggesting entire lines of code, sometimes even whole functions. It basically promises to write your code for you, freeing you up to focus on the big picture problems.
I mean, that's an amazing leap forward for sure, but it also raises a really critical question. If an AI is writing the code, can you actually trust what it's writing?
To get to the bottom of that, we first have to understand what this thing really is. So, let's properly meet your new AI pair programmer.
The official term for it, the one researchers use, is an AI pair programmer. Just think of it like this. It's an AI system that's built to help us humans out by spitting out code suggestions in real time, right as we're working, right? This isn't your old school autocomplete. It's way smarter. It understands the context of what you're doing.
So where does all this brainpower come from? Well, Copilot is built on a model called OpenAI Codex, which is a cousin of GPT-3. And here's the really crucial part. It was trained on billions upon billions of lines of code from public repositories on GitHub. It essentially learned how to code by reading almost all the public code we, as a community, have ever written.
And all that training has made it insanely popular. So let's talk about the promise of productivity for a second, and really get into why developers are so quick to embrace their new AI assistant.
It's way more than just suggesting code. Copilot is weaving itself into the entire developer workflow. It can act as a chatbot right in your editor, it can summarize changes in a pull request, and even help you with code reviews. It's like a whole suite of AI tools designed to make every single step of building software faster. And this table here really shows you how GitHub has packaged it up for, well, pretty much everyone. You've got a free version for people who just want to kick the tires, a pro plan for serious individual developers, and then an enterprise version for big companies. This just goes to show how deeply this tool is getting baked into the professional software world.
But with any revolutionary tech, there's always a catch. And now we get to that little glitch in the code, that hidden risk that comes from the fact that it learns from, well, everything.
And this right here is the heart of the problem. If Copilot is trained on all the public code on GitHub, that's not just the brilliant, secure, super optimized stuff. It's also learning from the bad code, the buggy code, and the flat-out insecure code. So what happens when it starts learning from our mistakes?
And this isn't just me guessing here. The researchers who study this put it very bluntly in their paper, which they called asleep at the keyboard. They said, and I quote, "It is certain that the language model will have learned from exploitable, buggy code. It's not a question of if, but how much. And that certainty is exactly what they decided to measure."
So with that certainty in mind, a team of researchers put Copilot right under the microscope. They came up with a really clever test to figure out just how often it would make these kinds of dangerous mistakes.
Now, to do this right, they couldn't just ask it random stuff. They designed 89 very specific scenarios. And these were based on a super well-respected list from MIT called the Top 25 Most Dangerous Software Weaknesses. Basically, these are the most common and damaging bugs that cause real-world security breaches.
Their process was pretty straightforward, but also really thorough. First step, they created code prompts where a security mistake was likely to happen. Second step, they had Copilot generate 25 different answers for each of those prompts. And finally, the third step, they analyzed every single one of those suggestions using both automated security tools and good old-fashioned manual inspection.
And that brings us to the big reveal, the climax of their investigation. What did they actually find? Well, get ready for what they called the 40% vulnerability verdict.
So, across all of those tests, in all of those scenarios where a security flaw was possible, what percentage of Copilot suggestions were actually vulnerable? The answer, roughly 40%.
Okay, let's break that number down. Out of nearly 1,700 programs that Copilot generated for the study, a full 40% of them had a security vulnerability. Think about that for a second. That means in these risky situations, 2 out of every 5 suggestions were insecure. That's a lot.
And what's so cool about this slide is you can see a perfect real-world example. On the left, you've got Copilot suggesting some code for a login function. Looks fine at a glance, right? But it's actually vulnerable to something nasty called a SQL injection. And then on the right, you see the proof,
A security scanning tool called CodeQL flags it and says, whoa, nope, this is dangerous.
But here's where it gets even more interesting. It's not just a flat 40% risk across the board. The danger changes a lot depending on the specific type of bug. For something like cross-site scripting, Copilot was only insecure about 19% of the time. But for path traversal, that's a bug where an attacker can access files they're not supposed to. A whopping 60% of its suggestions were vulnerable.
So, what do we do with all this information? Should we just toss the tool out? No, absolutely not. It just means we need to think about how we use it. The big takeaway here is this: you have to treat it as a copilot, not an autopilot.
See, the issue isn't that Copilot is malicious or, bad. It's just a crazy powerful pattern matching engine. It faithfully copies the patterns it saw in all that training data. And that includes both the good coding practices and the really, really bad, insecure ones. It doesn't understand why something is a security risk. It just knows, hey, I've seen this pattern before, so here you go.
The researchers' final piece of advice is probably the most important message of all. They said developers should remain vigilant, or as they put it, awake, when using Copilot as a copilot. It's a tool to help you, not to replace your own brain and your own expertise.
And that really leaves us with a huge question for the future. As AI starts writing more and more of the software that runs our entire world, who's ultimately on the hook for its security? Is it the developer who hits accept on the suggestion? Is it the company that builds the AI? Or is it someone else entirely? That's the conversation we all really need to start having.